trial, 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 trial,
Please mute.
trial, 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 trial,
Assalamu alaikum to everybody. It's 2:35. Let us start.
trial,
In the previous class, we were discussing about factors
Trial.
affecting root mean square velocity. We have discussed what is the expression for root mean
Trial.
square velocity, and then our job is to find out the factors. So yesterday we said RMS velocity depends upon temperature. Yes, it is correct. It depends upon
Trial.
molecular mass. It depends upon inversely proportional to square root of molecular mass. Then you said something that pressure has no effect,
trial,
right? RMS velocity is unaffected by pressure. Then there was a question which has been created yesterday, that what is the effect of density on RMS velocity?
trial,
That was a question for a thought process of all the students. Anybody got idea that how should I write that RMS velocity and
trial,
pressure? I am not asking about Moise pressure. I am asking about density. Pressure is over yesterday.
trial,
All right. Now we are having this one, that RMS velocity depends upon what? It depends upon density or not. Yes. Right. Mohammed Moise saying V RMS is equal to 1 by root D,
trial,
something indirectly proportional to root D. Right. Rahman, Saidur Rahman. In science, we don't use the word indirectly beta. Indirectly supermatic language है, inversely बोलना, ठीक है? सीखने का स्टाइल है, सीखने
trial,
का टाइम है, सीख लीजिए. Inversely बोलना, ठीक? Indirectly नहीं बोलना. So RMS velocity is inversely proportional to square root of density. Very good. Now,
trial,
if you say so, I am having a doubt. I am now behaving as a student. I am having a doubt.
trial,
When you are saying that if you increase the pressure, volume decreases, therefore density increases. That means actually what you are doing, you are creating
Trial.
relation between pressure and density. If his pressure is increased, then density also increases.
Trial.
Hence there is no effect. Why don't you apply the similar type of logic in case of density? Why you are saying that velocity is inversely proportional to square root of density? Are you able to follow my point? As a student, if I am asking a
Trial.
doubt, sir, you said that if you increase the pressure, density also proportionately increases. Why don't you reverse the sentence and you can say same thing is applicable if you have
Trial.
increase in density, pressure increases, therefore RMS velocity should be unaffected by density, but all of you are saying it is inversely
Trial.
proportional to square root of density. Anybody can tell me what is the reason for that? The answer is acceptable. Very good. You are saying velocity, RMS
Trial.
velocity is inversely proportional to square root of density. Very good. Now, why you are saying it is independent of pressure? Because if you increase the pressure,
Trial.
density increases. I am saying that why don't you apply the similar thing in a reverse way? If you apply increased density, sir,
trial,
pressure increases. Therefore, there should be no effect because of density. Why you are saying this statement? Any
trial,
reason for that? Okay, right? No, as a student, you will not have any reason. Listen to me. Listen to me carefully.
trial,
Remember that pressure is external property. Pressure is external property. If there is a change in
trial,
external property, remember there will be change in or effect on internal property. If you are changing the external property, remember internal property is affected. But
trial,
if you change the internal property, external property will not be affected, right? Some of you are having still confusion,
trial,
ye internal kya hai, external kya hai, right? Let us take a suitable example to your maturity. Suppose, for example, you are having offline classes and there is a rainy
trial,
season. And one fine day when the class is going on, one boy came slightly late and it was rainy. And bad luck, he was not having
trial,
umbrella. So he came into the classroom and he was somewhat having all rain on his
trial,
complete wet situation is available. He came into the class. He don't want to miss the lecture. He went out and he sat down on the on a particular place in a bench. And bad luck, there is exactly this is below the fan. What will
trial,
happen? Suppose, for example, if that fellow is sitting, then he will start sneezing, छींकना शुरू करेगा. जैसे ही अंदर भीगा भीगा हुआ आया क्लास में, वहां जाके बैठ गया, छींकना शुरू कर दिया. तो सर पूछे
trial,
कि बेटा क्यों छींक रहे हो, क्यों छींक रहे हो? छींकना इंटरनल प्रॉपर्टी है. बच्चा बोलेगा सर बारिश में भीग चुका था इसलिए छींक रहा हूं. एक्सटर्नल प्रॉपर्टी इज प्रेशर. इफ यू अप्लाई प्रेशर,
trial,
इंटरनल प्रॉपर्टी डेंसिटी चेंजेस. ठीक है, एक दिन गर्मा का दिन है, वेरी हॉट सनी डे इज देयर एंड
trial,
द सेम बॉय से फॉर एग्जांपल केम इनसाइड द क्लासरूम एंड ही वाज सिटिंग एट द सेम प्लेस एंड ही स्टार्टेड स्नीजिंग अगेन, छींकना शुरू कर दिया. अब बोले सर कि बेटा अब क्यों छींक रहे हो? तो लड़के ने ये जवाब दिया, द बॉय सेड दैट सर, since I
trial,
am sneezing, see outside there must be rain. Since I am sneezing, see outside the window there must be rain. No, ऐसा नहीं है.
trial,
If you are changing internal property, external property will not be affected.
trial,
Pressure is external property. If you change the pressure, internal property density is affected. But if you change internal property density, there will be no
trial,
effect on external property. That is the difference between influence of external and internal property. Therefore, yes, RMS velocity is directly proportional to square root of density. Yes, very good. Your conclusion is right. Now, write
trial,
down that statement. Come on. Once you understand this, then let us go back again to the same story.
trial,
Okay, nice. Very good. RMS velocity is
trial,
inversely proportional.
trial,
I think still you people are declaring your password and icon, and that same idiot
trial,
is in the classroom, right? Rami Nasalita. Suppose, for
trial,
example, if we are talking about this one, माँ बाप के नाम पे कलंक है सर, मुसलमान
trial,
कौम पे नाम पे धब्बा है, इंसान के औलाद है, कुत्ते की औलाद.
trial,
वही वजह से मरते नहीं, मौत नहीं आती, कमी नहीं.
trial,
Right. Now, once you are talking about velocity, RMS velocity, or what you are saying that root means square velocity and all the remaining things.
trial,
Let us some
trial,
relation between them. V
trial,
empty velocity, minimum velocity, you said. V average velocity, slightly more than
trial,
that. and V RMS velocity, largest possible velocity. All right.
trial,
Under root 2RT by M.
trial,
This is 4 marks question. Under root 8RT by pi M.
trial,
Under root 3RT by M.
trial,
Right. This is normal equations, but that fellow will ask you relation. How to proceed? Very simple. Root 2
trial,
RT by M cancels. 8 by pi
trial,
root 3. Right. Some people say this answer as it is, they will give this answer.
trial,
Right. Some people say if you simplify this, the smallest number here in this case is root 2. If you divide throughout by root 2, then we get
trial,
1 is to 1.128 is to 1.224. Right. Sometimes if they say like this, that
trial,
we can relate all of these relations, we can relate it. And suppose, for example, if you want to reverse it,
trial,
larger to smaller, V RMS. If you remember, it is better, especially doctors. V average, V
trial,
MP, higher to lower value. Then we can say this is, if it is 1,
trial,
this is increasing number, this must be decreasing number. What is decreasing number? Remember these relations, 0.9213, 921 is enough for us, and 0.816. Remember these
trial,
relations. Okay, now suppose, for example, you are saying that RMS velocity is directly proportional to, all these are numerical problems, straightforward.
trial,
RMS velocity, not only RMS velocity, all the velocities are directly proportional, inversely proportional. Directly proportional, we can say
trial,
for molecular mass. Inversely proportional, we can say inversely proportional to molecular mass. I'll take two separate, right? Let us take both of them separate. First, I'll take root 2. What is the
trial,
conclusion here? This means to say, as you increase the temperature, velocity increases, right? Now, if you want to
trial,
understand this, let's see what happens. Suppose, for example, if I take RMS velocity, what is that? dN by dt, fraction of
trial,
molecules along y-axis, and what we have taken here, velocity along x-axis.
trial,
Now, what was the type of the graph? The type of the graph was something like this.
trial, trial,
This is, say, for example, a temperature T1. Now, if suppose you are increasing temperature, then see the graph, right? They'll ask you
trial,
theoretical question, they'll ask you graph also.
trial,
And if you further increase temperature, this is, say, for example, T2.
trial,
If you further increase temperature, the graph becomes further broader. Like this. This implies when you are increasing temperature, what is
trial,
happening? What is your observation? All this is simply direct possibility of question is there. What is going on? See
trial,
carefully. Conclusions are like this. A. Each conclusion
trial,
a question. As the temperature increases, every velocity is increasing, right?
trial,
Velocities are shifting, right? Remember, the graph is shifting towards right hand side. T1, T2, T3. T3 is more than
trial,
T2, more than T1. If suppose you are increasing temperature, as the temperature increases, velocity increases, right? But what you are observing, fraction of molecules are
trial,
decreasing. See the height. This is fraction of molecules. This is fraction of molecule. This is fraction of molecules. Okay. Fraction of molecules
trial,
with certain velocity.
trial,
Decreases. Graph is becoming wider, right? People say like
trial,
this. Graph becomes
trial,
wider. What is the physical meaning of this? Distribution is large. We are having large number of
trial,
students with this velocity and this velocity. Distribution is higher. Distribution is increasing.
trial,
Increases. Next. The main thing which happens here in this case is as you are increasing temperature, see
trial,
here, when you are increasing temperature, there is effect on these molecules, very high effect is observed. Only this many molecules are available with very high velocity. But when you increase temperature, this becomes
trial,
doubled sometimes, this becomes tripled sometimes. Therefore, with increase of temperature, as the temperature increases, fraction of molecules
trial,
with
trial,
higher velocity increases, right?
trial,
That is the meaning of this one. As you are increasing temperature, we are having same. Acha. Once you are talking about this one, remember one point that fraction of molecules are changing. We are
trial,
having change in the graph, but that fellow says, what about the total number of molecules? Remember, area under the graph is known as total number of molecules. It remains the
trial,
same, right? Area under the graph
trial,
is always 1 because you are saying fraction remains constant.
trial,
Independent of temperature.
trial,
Okay, this is one thing. Next thing is, suppose for example you are saying, sir, I want to enjoy the game.
trial,
Velocity RMS is inversely proportional to either you say molecular mass or you say density.
trial,
Yes, if it is so, then how do you enjoy this in terms of graphical representation?
trial,
Here I have to take fraction of molecules as usual.
trial,
And here I'll take the velocity. Come on. What happens? There is a graph given like this.
trial,
There is a graph given
trial,
like this. And there is a graph given like this. Right?
trial,
He declared that temperature is constant. Right? And he has given you 3 gases.
trial,
One is helium, one is methane, and one is oxygen. And now he is asking
trial,
which graph belongs to which gas. How do you proceed? Very simple, sir. It is of lower molecular mass. If molecular mass is more, the gas can occupy, the gas can enjoy
trial,
higher velocity. The gas can enjoy higher velocity. Therefore,
trial,
if we are talking about helium, then in case of helium, we should have a chance to enjoy very high velocity. Therefore, remember, this is for helium. And
trial,
oxygen, molecular weight is more among all the 3. If molecular mass is more, they cannot have very high velocity. Therefore,
trial,
this is for oxygen and this is for methane. That is the effect of molecular mass and temperature on RMS.
trial,
Go ahead.
trial, 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 trial,
As temperature increases, velocity increases. Fraction of molecules with certain velocity decreases. Graph becomes wider,
trial,
distribution increases. As temperature increases, fraction of molecules with higher velocities increases. Area under the graph remains always 1, remains constant and is
trial,
independent of temperature.
trial, 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 trial,
Total of fraction is always equal to 1.
trial, trial,
Is it over?
trial, 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 trial,
Next.
trial,
No, that is the end of what we can say RMS velocity or other type of velocities. We are having problems possible here, but
trial,
mostly हाँ अब आपको तमीज आई अनस हाँ अब आपको तमीज आई है इसलिए मैं चेंज किया था इंसान को अपने कपड़ों के अंदर रहना चाहिए बेटा अनस
trial,
yes you said wait to whom you are discussing idiot
trial,
what is that meaning of wait
trial,
इंसानियत सीखो बेटा इंसानियत सीखो बहुत हो गया देख रहे ना वो गधे आ रहे हैं जा रहे हैं खत्म हो रहा क्या हो रहा आ रहे हैं अंदर लात मारे चले जा रहे हैं सीखो कम से कम आप लोग सलीके से बैठ रहे हैं सुन रहे हैं तो सीखो पहले अदब सीखो पहले
trial,
अदब सीखो बाद में ये सब अल्फा बीटा गामा काम में आने वाले हैं बेटा पहले अदब सीखो अपने अखलाक जाहिर होते हैं इंसान के चले प्रोसीड
trial,
no
trial,
in case of problems of RMS velocity, we have very
trial,
simple discussion. What is that? Basically, we have only one formula. What is that? Under
trial,
root 3 RT by M for RMS velocity and under root 2 RT by M, they think. But we want to avoid those type
trial,
of calculations. Therefore, let us see how to proceed for that. Calculate the root mean square velocity, average velocity, and RMS velocity. He's asking all those things, but we don't have that much time. And you people are
trial,
genius, you can understand. He's asking calculate RMS velocity. He's asking average velocity, and he's asking NP velocity. All these are there. Only one is enough
trial,
for us, and we can proceed for the remaining thing. Okay. Question number 1. He's saying oxygen
trial,
at STP. At STP. Now, remember that whenever such type of problem is given to you, very simple way of discussion is whenever temperature is
trial,
given to you, sir, here pressure is also given, no problem. But whenever you have the temperature value available, don't see any other thing. Simply directly what you have to say,
trial,
under root VRMS is equal to under root 3 RT by M. But in the
trial,
previous class, I have shown you that it is to be simplified. What was that? 1.58 under root
trial,
T by M into 10 power 4 centimeters per second. Remember this point. Come on.
trial,
How to proceed? 1.58 under root T. What is T? Sir, STP 273 by molecular mass 32 into 10 power 4. Right? Simply write down this
trial,
much. When I complete the whole story, calculations you do at home later on. No problem. This is first type of problem. Second type of problem, in case of RMS velocity, ethane, find RMS velocity of
trial,
ethane C2H6 at 27 degrees centigrade and 720 millimeter of Hg.
trial,
Remember, Whenever temperature, just now as I said, whenever temperature is given to you, don't see any other thing, right? Straightforward go to temperature, and you can substitute the value of temperature and directly we can
Trial.
proceed even though pressure is given. Sir, here it is given as 760 millimeter, here it is given as 720 millimeter. Okay, no problem. Always we
Trial.
talk about RMS velocity preferentially with respect to temperature, because yesterday you said there is no effect of
Trial.
pressure on RMS velocity. Are you able to enjoy the concept? Yes. Is equal to 1.58
Trial.
under root T by M into 10 power 4 centimeter per second. चलो ठीक है. Next, C.
Trial.
Oxygen. Again he is saying oxygen. If density is another
Trial.
type of problem, 0.0081 grams per liter. ठीक है. At 1 atmosphere pressure. Pressure is equal to 1
Trial.
atmosphere. Now, when you are having this one, there is no temperature. Therefore, we can go by application of pressure. See here, roll number 1,
Trial.
roll number 2. These students are doing some different technique. What they are learning, sir, in these two problems, you are insisting upon temperature. So we are making our mind, okay, always hum temperature se hi
Trial.
game khelenge. Tab I can do like this. PM is equal to DRT. This is one way of enjoying the
Trial.
problem, sir. I know the value of pressure. I know the value of molecular mass. I know the density in CGS system. Very good. 81 into 10 power minus 4. I know the value of R and temperature.
Trial.
When we are discussing this, then what we can say, find out the value of temperature. Sir, I got it. Once you got temperature in kelvins, then same story. Vrms is equal to
Trial.
1.58 under root T by M into 10 power
Trial.
4 centimeter per second. Rule number 2 say, no, sir, I want to enjoy some different method. No
Trial.
problem. Physical chemistry, no one should say this is the only method of doing problem. Everyone is having their own enjoyment. Only the thing is, you should be very strong in concepts. Remaining things are in our control.
Trial.
That is like that. No, sir, I want to go like this. Vrms is equal to under root 3p by d. Yes, sir. Values are given. I go like this only. Is equal to under root. Now
Trial.
we have to be careful. This is safe side. Slight lengthy, 2 steps, but this is a smaller one. Safe method is somewhat
Trial.
risky. What is the problem? The problem is when you are talking about this must be either in CGS system or in MK system. CGS system, yes sir, we are having grams per liter available, but here 1 atmosphere.
Trial.
Therefore, always try to convert into MKS style, SI units.
Trial.
How to proceed for that? Very simple, sir. Density is equal to, I'll write 81 into 10 power minus 4, right? Grams per liter. I should write like
Trial.
this. Learn the conversions, doctors. Learn the conversions. 81
Trial.
into 10 power minus 4 into 10 power minus 3. This becomes as kilograms. 1 meter cube is equal to 1000 liters, right? Therefore, 1 liter is equal to.
Trial.
Are you able to understand? Therefore, finally answer becomes as 81 into 10 power minus 4. कुछ भी change नहीं हुआ देखो, right?
Trial.
Therefore, grams per liter, kilograms per meter cube में हमेशा ऐसा ही होता है. ये हो गया. चलिए density ये हो गया. अब pressure का problem है. How to go for pressure? Very simple, sir.
Trial.
We have already written that 1 atmosphere is equal to, कुछ याद है? 1 atmosphere is equal to 1.013 into 10 power. ये नंबर आप छोड़ सकते हैं approximately 10 power 5. What was that? Pascal. And what is Pascal? Pascal is Newton per meter square, right?
Trial.
Isa, if you want to go out of the class, you can go better, right? Either you concentrate on the class or you want to go out. आप किसी की वकालत करने का है तो आप एजेंट का ब्रोकर का काम कर लीजिए बेटा, मेरी क्लास में से चले जाइए, ठीक है? I have locked the class because some your friends, right? आपके जो हरदिल अजीज बहुत शरीफ और मुहज्जिब दोस्त हैं आपके, वो लोग आ गए थे क्लास में, उन हरामियों को हकालने के लिए मैं लॉकअप किया हूं. आप अपना काम कीजिए, पढ़ना है तो पढ़िए सलीके से, नहीं तो प्लीज खुदा के वास्ते घर को जाइए. उसके लिए लॉक खोलो, इसके लिए लॉक खोलो. आप वो काम करते बैठो बेटा व्हाट्सएप पे. मैं पढ़ा रहा हूं, मुझको स्टूडेंट्स चाहिए, राइट? गधों की जरूरत नहीं है. Thank you. Please go. Otherwise, you are interested. Please be along with me. Welcome you 10 times. If you substitute the values of pressure and density, go. क्लास में है क्या व्हाट्सएप पे? इसके बाद उसके बाद फोन पे करते बैठे हैं, राइट? Come on, go ahead. Please square. Please to the power 10. If you are interested, please come to my class. I am not a good teacher. Please, if you're interested, come to my class. Otherwise, complain against anybody. Go ahead. You just leave the class and say, Arif sir is not well. Good. Not a good teacher. Very good. I will be very happy to leave the class. पढ़ने का सलीका सीखो बेटा. पढ़ना तो आप लोग अभी नहीं सीखे. पढ़ने का सलीका सीखिए. Go ahead, boys. Go ahead. Go ahead. First method is ठीक है, 2 step करना पड़ रहा है, but I prefer that method because I am having a chance of getting mistake in all these conversions because I will be under tension in examination hall. Therefore, it is always better to be in single step.
Trial. Trial.
When you are in the class, remember you are alone available. I am alone available. बाकी के सब dead bodies हैं. ये रूल बनाइए अपने आप का. आप हैं और मैं हूं, बस दोनों काम कर रहे हैं. बाकी के सब पूरे डेड बॉडीज हैं. कुछ पाने के लिए कुछ करना पड़ता बेटा. खाली जो टाइम पास के ऐसे क्लास अटेंड करे तो ना. एम्स तो खैर बहुत दूर की बात है, आईआईटी दूर की बात है, उसकी खुशबू भी नहीं आएंगी आपको. सीखो अदब से, आराम से, सलीके से सीखो. क्या होना पूछिए. आप समंदर के सामने बैठे हुए हैं, क्या होना बोलिए. यस, आई एम रेडी.
Trial.
Go ahead, go ahead. These are the 3 methods with which we are varying conditions. 4th method.
Trial. 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 Trial.
There is a problem. In second method, either you to go to CGS system or MK system. अब CGS में फिर और मुसीबत होती है. अर्ग्स में जाना थोड़ा सा मुश्किल नहीं है, थोड़ा सा टाइम लगेगा. और हमारे पास टेंशन होने की वजह से, बिकॉज इन एग्जामिनेशन हॉल वी विल नॉट बी नॉर्मल कंडीशन. आप जिस नॉर्मल स्टाइल में अब बैठ के काम कर रहे हैं, उस वक्त वो नहीं रहता. देयरफॉर हमेशा go to safer side. Longer side is no problem, but safer side. Here we are trying to convert all of them either in SI units or in CGS. Here, no discussion, sir. It is in grams per liter, and we are having pressure atmosphere because our value is liter atmosphere. Smooth. Chaliye. Here he has given answer as 4.6. लिख लीजिए, बाद में देख लीजिए, करेक्शन बाद में कीजिए, because it needs all calculations. 10 power 4. Right? Okay, you have given 10 power 7. यहाँ 10 power 4 है तो 10 power 7 आने का तो क्वेश्चन ही नहीं है. आराम से करो, भागने की जरूरत नहीं है, आराम से करो. And the second case.
Trial.
4.99 he said. Ten to the power 4.
Trial.
और यहाँ in C 4.75. Whatever be the method, answer should be same.
trial,
Please don't waste time. Just write down the answers and go ahead. कभी फ्री है तो आप कैलकुलेशन कर लीजिए. Shall I proceed? Is it over?
trial,
Go ahead. Go ahead.
trial,
Write down. Write down.
trial,
No problem.
trial, trial,
Right.
trial,
Okay. Fine. Moise is saying it's over. Anybody else? Should I wait? Shall I proceed? Anas, हो गया?
trial,
Abrar, is it over? Fine.
trial,
Go ahead. Go ahead. No problem. Write down. Write down.
trial, trial, trial,
Faiz Nawab, is it over?
trial,
You're reading 6, 10 power 3. No problem. No problem. Check it later on. Check it later on. Write the correct answers in brackets. Right? आपका जो आंसर है वो ऐसे रखिए बाजू ब्रैकेट्स में आप ये आंसर लिखिए
trial,
जब आप फ्री हैं थोड़ा सा चेक कर लो राइट कम ऑन नेक्स्ट क्वेश्चन see the next bit what he has given the fourth way of doing the problems एक ही प्रॉब्लम में सब हो गया
trial,
the oxygen if 6.431 gram 6.431 gram occupies 5 liters at 1 atmosphere. Sorry, at 750 millimeter of Hg.
trial,
चलिए अब क्या करना है कुछ भी नहीं करना है सर हमारा कॉन्सेप्ट है कि वी आर ऑलवेज ट्राइंग टू इंसिस्ट अपॉन
trial,
टेम्परेचर ठीक है weight is given something is given therefore I'll do simply PV is equal to nRT.
trial,
You people are genius. I can write N as weight by molecular in the first step only. RT. What is pressure? 750. No, sir. We should not
trial,
use millimeter. We have to use atmosphere into volume. Volume should be in
trial,
liters. Weight is 6.341 grams divided by molecular weight of oxygen into R 1 by 12, 1 by 12.18 if you want to be precise. Temperature.
trial,
I got the value of temperature in kelvins. After that,
trial,
RMS velocity is equal to 1.58
trial,
under root P upon M into out of the root 10 power 4 and it must be in CDS system. If he's asking in MKS, change it later on. Go ahead.
trial,
These are the different possible problems, suitable type of methods. Go ahead, then I'll proceed to another question. Complete
trial,
this one.
trial, 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 trial,
There
trial,
is a question given in IIT 90, T1, T2 is equal to how much? Average velocity
trial,
of carbon dioxide at T1 kelvins is equal to average velocity, MP velocity of same carbon dioxide at T2, and both of the values
trial,
are 9 10 power 4. Difference is what? Temperature is different. So he is asking what is T1 and T2. Very simple, sir. Right? IIT people can enjoy very
trial,
easily, but NEET people, yes, sir. We also know very well mathematically because last year only we have. Last year we are having same thing, right? No BPC, no
trial,
MPC. We are now differentiating. So don't have a phobia of mathematics, right? Now, how to proceed? First of all, average velocity at T1 kelvins is
trial,
equal to NP velocity at T2 kelvins is equal to 9 into 10
trial,
power 4. ठीक है, ये हो गया अंडर रूट 2 RT,
trial,
सॉरी 8 RT by pi m, राइट? रूट नीचे से लाना है पूरा,
trial,
and this is equal to what was that? Under root 2 RT by m, 2 RT by m.
trial,
No, sir, this is T1, this is T2, right? This story is finished because the same gas is available.
trial,
Simplify, neither you get T1 nor you get T2, but you can have some relation between T1 and T2, right? Use the relation and come here. Any one value. Suppose, for example, you are saying MP velocity is
trial,
equal to under root 2 R T2 by M.
trial,
MP velocity is a T2. So we have VRMS velocity, sorry, MP
trial,
velocity, how much? 10, 9, 10 power 4 is equal to under root 2 R value 8 by, here it is in centimeter, therefore 8.314 into
trial,
10 power 7 ergs, okay? Temperature, you have created relation between T2 and T1. So substitute T2 in terms of T1. So we'll get some number here in this case in
trial,
terms of T1 divided by molecular mass. What is molecular mass? 44. I got the value of T1.
trial,
Substitute T1 here in this case. We got T2 also. Okay. Relation can be. Go
trial,
ahead.
trial, 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 trial,
Okay, no problem, right? Shoaib 1689. ठीक है चलेगा.
trial,
2142. No problem, no problem.
trial,
Is it over? Shall I proceed?
trial, 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 trial,
Fine. Now, we have done one more equation in our discussion. PV is equal to 1 by 3 capital M V RMS square,
trial,
kinetic gas equation. Sometimes we have problem based on that also. Now, let us take next problem. Calculate RMS velocity,
trial,
total
trial,
energy, and average translational energy.
trial,
Average translational energy in 8 grams of
trial,
methane. In 8 grams of methane
trial,
at 27 degrees centigrade. Now, this is the question. How to proceed? Okay, come on. First of all,
trial,
RMS velocity. Since temperature is given to you, straightforward we can go. Sir,
trial,
RMS velocity is equal to, what was that? 1.58 under root
trial,
P by M into, you got it. Next one is kinetic
trial,
energy. What is kinetic energy? Sir, there are two words which are used here in this case. Yes, remember that the energy expression we have done in our class
trial,
notes, kinetic energy is equal to 3 by 2 nRT. This is known as average translational energy. It is called average translational
trial,
energy. But the question is, when he is saying total and translational, it is because he is asking about 8 grams. So for that purpose, how do you proceed? Very simple,
trial,
sir. Let us take first one, total kinetic energy is
trial,
equal to 3 by 2 N. What is N? Weight by molecular weight.
trial,
Weight by molecular weight into R, temperature 300. This must be
trial,
in terms of, now there is a problem. When you take 1 by 12, again you have liter
trial,
atmosphere, that is not accountable. Therefore, remember, since energy should be expressed in terms of joules, therefore 8.314, what is to be written? Now you are comfortable with joules. Otherwise, your rate in terms of liter
trial,
atmosphere. That is also acceptable units, but we don't use that until now. आगे आएगा, अगले chapter में आएगा. Now, what is the meaning of average kinetic energy? What is
trial,
this? This is joule per mole, per mole. Okay. The average kinetic energy means
trial,
kinetic energy per molecule. Are you able to understand that? In the classroom, we have said
trial,
something known as Boltzmann constant. That is total kinetic energy by dash.
trial,
This is per mole. This is what I write per molecule. Go ahead.
trial, 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 trial,
Velocity you got 6.8 10 power 4.
trial, trial,
6.83. Very good. You are right. Velocity, Abrar is
trial,
saying it is supposed to be 6.84. Nice.
trial,
Correct. You are right. Shoaib, answer is correct. 1875 joules. Total kinetic energy
trial,
1875 joules. No problem. He is saying 1871.42.
trial,
1875 ठीक है चलेगा. No problem. No problem. Right. And this fellow is saying 62.14.
trial,
10 power minus 22
trial,
into 10 power minus 22.
trial,
What is that? Mohammed Zahiruddin. Zahiruddin is asking a very good
trial,
question. He's asking, sir, I wanted to clarify that average translation energy and average kinetic energy both are same or not. Yes,
trial,
both of them are same. But suppose, for example, if he is saying something with respect to weight,
trial,
right? 8 grams. 8 gram is not mole. Okay. If suppose that 8 grams are given
trial,
or some molecules are given, then we say average means per molecule. Average means per
trial,
molecule. Otherwise, remember total transition energy, average transition energy, average kinetic energy, all are one and same,
trial,
because we have said in our classes that it is not possible to find out the absolute kinetic energy. Okay. Hope answer is doubt is clear. Mohammed Shujauddin is having a doubt, dash 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 dash
trial,
question mark. I am unable to read that one because it is not chemistry. Remaining discussion we'll discuss in the next class.
Trial.
Thank you.
Trial. Trial.